So welcome to the welding technology course. Course code is PR8592 and it is a professional elective subject for the regulation 2017. And here in this video session, we'll be studying about the gas and arc welding process in unit 1. And then in this session, we'll be studying in detail about the gas welding. So the objectives of studying this welding technology course is to understand the basics of welding and to know about the various types of welding process. So unit 1, gas and arc welding process, we have all these topics, fundamental principles of welding, air acetylene welding, oxyacetylene welding, carbon arc welding, shielded metal arc welding, submerged arc welding, TIG and MIG welding, plasma arc welding, electroslag welding processes, and applications, advantages, and disadvantages of all the gas and arc welding process. So here we'll be studying about the gas welding process, and it is a fusion welding process. So gas welding is nothing but it's a fusion welding process. So it joins metals using the heat of combustion of an air and fuel gas, that is acetylene, hydrogen, propane or butane mixture. So the flame thus produced would melt and fuse together the edges of the parts that are to be welded, and either they use an addition of the filler metal also. So this is a gas welding setup. Here you have the gas welding. It is a type of liquid state welding process in which fuel gas burns to generate heat. So you require heat here to heat the edges of the metals and to melt the metal to a molten stage. Okay, this heat is used to melt the interface surface of the welding plates. So here in the diagram you have two metals which are to be welded. These are the two welding plates and they are held together to form a joint. So in this welding process, mostly oxyacetylene gas. So this black cylinder is the oxygen cylinder, and the other color cylinder is an acetylene cylinder. So here in this welding process, oxyacetylene gas is used as a working fuel. So this process can be done either with or without the help of a filler material. So acetylene is mixed with oxygen in correct proportions in the welding torch, and it's ignited. So the flame is sufficiently is very hot to melt and join the parent metal, and the oxyacetylene flame produced would reach a temperature of 3200 degrees Celsius, and care has to be taken that the tip of the torch is pointing downwards, and the flame is controlled through valves situated in the welding torch. So you have the control knob here to control the gas in the welding torch. Now the flame is controlled through valves situated in the welding torch. So the flame is set at a neutral flame or carburizing flame or oxidizing flame according to the welding condition. And now the welding torch is moved along the line. So this welding torch is moved along the line and where joint to be created. So this weld, edges of the metals get heated and filler rod is melted to fill up the gap, and this will melt the interface part and join them permanently. So these are all the gas welding equipments. You have gas cylinders and pressure. Oxygen is 125 kg per centimeter square, and the acetylene you have the 16 kg per centimeter square, and you have this regulators. Working pressure of oxygen is 1 kg per centimeter square, and this regulators will control the pressure of the oxygen and acetylene, and the working pressure of acetylene is 0.15 kg per centimeter square, and this pressure, working pressure, varies depending upon the thickness of the workpiece being welded. And you have this pressure gauges, hoses, welding torch, check valve, and non-return valve. So this is all this parts has been explained here. And this is the oxygen cylinder, and the bigger one is oxygen cylinder, and this is the acetylene cylinder, and you have this regulator valves, oxygen regulator valves, and this is the acetylene regulator valves, and this is a welding torch, and this welding torch is connected by hose, oxygen and acetylene hose to the cylinders. And here you have a torch oxygen valve here, knob, to control the flow of oxygen and acetylene gas into the oxygen this welding torch chamber, where this oxygen and acetylene is mixed in this chamber, and is after mixing it comes into this tip, where when lighted with a fire, it's get burned. So application of gas welding is mainly used for repair works, and most application of gas welding is for repair works, and it's used for fabrication of sheet metal, that is thin to medium sheet metals are welded using gas welding, and used in aircraft industry, used in joining various aircraft parts, and the automotive industry is used to weld the parts of the frames and the chassis, and joining high carbon steel. Gas welding is very effective in melting high carbon steel. So the advantages of gas welding is weld ferrous and non-ferrous metals. And one of the great strength of gas welding is that it can weld non-ferrous and ferrous metals together. So no requirement for electricity. So when we compare gas welding to other welding methods like arc welding, gas welding does not require any electricity to operate. Hence, you can use gas welding in places where electricity supply is not there. So it's a cheap equipment cost. So initial capital for this welding, gas welding, is very low, and you do not require any specialized machinery, and specialized labor not required, and the equipment is easily portable. So disadvantages of gas welding: this metal joining rate is very slow, and so the welding speed is low. And a skilled operator is required to operate this machine, and the power density is low, and the heat affected zone would be larger. And this gas welding is not recommended for welding like reactive and refractory metals like titanium and zirconium. So coming to the types of flames, you have the three types of flames, and neutral flame, oxidizing flame, and carburizing flame. So when oxygen is turned on, this flame immediately changes into a long white inner area. Inner area feather surrounded by a transparent blue envelope called the carburizing flame. So that is the temperature is around 3000 degrees Celsius, and this is three types of flame diagram. So addition of little more oxygen would give a bright whitish cone surrounded by the transparent blue envelope, and is called as a neutral flame. So this is the neutral flame, and you have the temperatures mentioned here, and it has a balance of fuel, gas, and oxygen. The temperature range is 3200 degrees Celsius, and this is used for welding steels, aluminum, copper, and cast iron. And if more oxygen is added, the cone becomes darker and more. So this is which is called the oxidizing flame. You have here the oxidizing flame, and you have a over envelope, and you have an inner cone, a sharp pointed inner cone. While the envelope becomes shorter and more fierce is called oxidizing flame, and it has a higher temperature of 3400 degrees Celsius, used for welding, brass, and brazing operations. So this is the diagram of our oxidizing flame as well as the carburizing flame. That is, you have a bright luminous inner cone and a blue envelope, and you have this acetylene feather inside the blue envelope. So these are all the three basic types of oxyacetylene flames used in oxy-fuel gas welding and cutting operations. So with this, we come to an end with this topic. So thank you and have a great day.